market risk. The most common tools which we would be discussing in this, one being the value at risk. Right, we will be dealing with different mechanisms to go ahead with the value at risk. Then we will look at what is called as estimated or expected shortfall. Expected shortfall measure. And we will also look at a coherent measure of risk and how these VAR and expected shortfall fit into that criteria also. So we will try to take up a data set and try to work around wherever it is possible, and we'll take a couple of smaller examples also to understand the topic much better. So just to get started with the value at risk part, there are multiple approaches to estimate the value at risk. The major broad categorization being the parametric approach to estimate the VAR, as well as we have the non-parametric approaches. So as we have discussed earlier also, parametric approach is nothing but it involves the data to follow some particular statistical distribution, and based on that probably I may get involved in terms of computation or estimation of some of the parameters like mean, variance, etc. Whereas when we talk about non-parametric, even if the data does not follow any kind of a distribution, I can try to do the assessment of the real, I can do the calculations whatever are required in case of a non-parametric, which means I am not expecting the data to follow any specific distribution, and no specific calculations of mean, median, etc. are required to be done. So the VAR we can estimate through either of these approaches, and in each of these categories again there are multiple methods to go ahead. Out of that, what I am picking up right now is under the non-parametric category we are looking at the historical simulation approach. So for that, let me take up a small data set to work around, so that you get it becomes more and more clear for you in terms of analysis. Alright, so I am taking a simple data set here which contains the closing prices of Nifty for the last 1 year. Right, the closing value of Nifty for the last 1 year. Now what I typically do in this approach is I try to find out the returns. I may compute the dollar returns or the rupee returns, or I may take the percentage returns. So let's say I am computing the percentage returns on a daily basis. I may take again a continuously compounded set of returns or a simple arithmetic return, which is either I can take the day 1 value minus day 0 value divided by the day 0 value and call that as an arithmetic return, or I could take the logarithm of day 1 value divided by day 0 value, which can give me the geometric return. To a large extent, if the time periods are very small, both of them will give me similar kind of result. Okay, so these are the returns both on an arithmetic as well as geometric format. And generally what we do is, whatever is the mechanism we have computed the returns, we arrange the returns in an ascending order. Just after the returns are computed, what I will do is I will take them onto a separate sheet. I arrange the returns in the ascending order. Okay, I am sorting the data and taking it in the ascending order. So let me do it again. I arrange the data in the ascending order. So this is the order in which the data is arranged. Now how many records are there? Probably if I go to the last, there are 250 records or 249 records. So when I am arranging the data in the ascending order, now I may be interested in finding out what is my 1% var or what is my 5% value at risk. So all that we are doing is identifying the 1% of the entire data. So in this, as we are seeing, if there are n observations, or probably how am I computing the var in historical simulation approach? The observation which separates the tail from the rest of the data. So for n observations with a significance level of alpha, the var is alpha into n plus 1 observation. So if I want 1% var, the alpha is 1. So all I am doing is alpha into n plus 1th observation. So alpha is 1% into n is 250 observations plus 1th observation. So it's almost 3.5th observation is what is we are taking as the var. Sometimes nowadays we are even seeing that plus 1 is not there. So we are taking the 2.5th observation itself as the var rather than the 3.5th. I mean, in some books we have it mentioned as 3.5th observation, whereas in some of them it would be mentioned as 2.5th observation itself. So whatever it is, if we are talking about the 2.5th, okay, this I know as the second observation, this is the third observation. So I can take the linear interpolation between these two, and I say that this particular data, so 2.5 is nothing but the average between these two. So I could very well say that my 1% var is around minus 3.67 percentage. Convert this into percentage, and probably I can say that my 1% daily var is, though the value comes out as minus 3.68, the usage term is 3.68%. We ignore the negative sign and we try to present it. So what does that mean? There is a 1% chance. There is